Hello all, welcome to my engineering physics channel. In this channel, we will discuss the 2024 pattern engineering physics, all topics and all units. The teaching scheme for engineering physics as per 2024 pattern are as follows. There are total 3 hours lecture per week for the theory, and for practical you have 2 hours lecture per week per batch. The total credits for engineering physics are 4. There is distribution of for theory you have 3 credits, and for practical you have the 1 credit. In 2019 pattern there is INSEM and end semester examination. The INSEM is for 30 marks and end semester exam is for 70 marks. In 2024 pattern, there are some changes. The INSEM exam will be replaced by CCE, and which is also for 30 marks. What is CCE? CCE is continuous comprehensive evaluation. In 2019 pattern, the INSEM was conducted by the university. In 2024 pattern, the CCE was taken in institute level only. And for end semester, you have a 70 marks paper for engineering physics. And for physics, you have the practical work for 25 marks. So in this channel, we will discuss all the 5 units of engineering physics as per 2024 pattern. So in today's session, we will start the unit 1, that is fundamental of photonics. The fundamental of photonics are divided into two types or two parts, that is laser and optical fiber. So in this session we will discuss about the laser. So let's start the session. So what is mean by laser? So laser, in this laser, we will discuss the basic idea about the laser, difference between ordinary light and laser light, different processes for the formation of laser, characteristics of laser, CO2 laser, applications of laser and some numerical problems. So let's start the session. So what is mean by laser, or what is the full form of laser? The full form of laser is light amplification by stimulated emission of radiation. So there is a amplification of light will be takes place. What is mean by amplification? The amplification means the increasing the strength of signal, and which signal strength is increased, that is light signal. And this process of amplification was taken by the stimulated emission of radiation process. So the laser has a parallel beam of light and which has the high intensity and high energy as compared to the X-rays. So what is the difference between ordinary light and laser light? So the laser light has a small divergence, whereas the ordinary light has a more divergence. That means a laser light consists of parallel beam of light. So it is travel, or it does not separate over the wide distance, whereas the ordinary light has a more divergence. That means a ordinary light will be spread or a separate over a distance. Next point for laser light, it is a highly directional source, whereas the ordinary light is not directional because it is spread over the distance. A laser light is a monochromatic source. So what is mean by monochromatic? Mono means a single and chroma, it is from Greek word which is used for color. In laser light, you have a single color of light. For example, red laser, green laser are the examples of laser light. And for ordinary light, you have a polychromatic source of light. So poly means many and chroma means color. So in ordinary light, there are a combination of different wavelengths or different frequency of lights. For example, a white light is a combination of 7 colors. Next is laser is a highly energetic. The laser light or a laser beam moves parallel to each other, so it is highly energetic. And for ordinary light, there is a poor energy associated with it. For laser light, as we discussed earlier in the full form of laser, there is light amplification by stimulated emission of radiation. So, in laser formation, the stimulated emission is used, or this process is used for the formation of laser. And for ordinary light, the spontaneous emission process is responsible. This process we will discuss later. And the example of laser light is CO2 laser, that is carbon dioxide laser, helium neon laser, ruby laser are the examples of laser light. Whereas for ordinary light, you have the example of sunlight or your LED light. So this is all about the distance or the difference between laser light and ordinary light. In the formation of laser, there are three energy states. So what are they? First is a ground state, second is a metastable state, and the third is excited state. So what is a ground state? A ground state is a lower level energy state which corresponds to lowest energy, which is known as ground state. And what is mean by metastable state? So metastable state or this state is an intermediate state between a ground state and an excited state, for which the atom will stay for 10 raised to minus 3 seconds. And the excited state is uppermost energy state of an atom, for which the atom will be stay for 10 raised to minus 7 seconds. So this all three states are necessary for the formation of laser. Now we will discuss one by one the processes that is involved for the formation of laser. So what is the processes? There are three processes for the formation of laser. The first one is induced or stimulated absorption. So in this process, the atom is in lower energy state which absorb the incident photon and jump to the excited level. This transition is known as stimulated absorption. So in this process, the photon of energy is incident on a ground state atom. So here E1 denotes the energy of ground state, and this photon was incident on this ground state atom. This atom absorbs the energy of this photon and it will jump to the excited state. So excited state is your E2. So the transition for this state can be written as A plus H nu gives us A star. So A is nothing but your energy in energy of an atom in a ground state. H nu is a incidenting photon and A star is atom present in excited state. The number of atoms absorbed can be written as NAB, which is equals to B12 N1Q delta T. So what is this B12? B12 is absorption coefficient. Why we are writing 12? Because your atom will jump from lower energy state, that is E1 to E2. So therefore we are using B12. N1 is denotes the number of atoms in a ground state. Q is the energy density and delta T is time required for this transition. So this is the first process for the formation of laser. Now the next post process is spontaneous emission. So this spontaneous emission process is a natural process. In this process, what will happen? Initially, your atom is in excited state. So in this excited state, the atom will not stay longer. So it will drop down to the ground state. And during this transition from higher level to lower level, it will emit a photon of energy H nu, which is absorbed in initial process, that is absorption process. What is mean by spontaneous emission? The excited atom E2 may return to the lower energy state by emitting energy or by emitting a photon is known as spontaneous emission, and it is a natural process. So this type of photon emission is known as spontaneous emission. So the transition can be written as A star giving rise A plus H nu. So A star denotes your atom initially present at a excited state. It will drop to the lower energy state. So A denotes the atom in a lower energy state, and H nu is photon energy. So the number of atoms which is involved in spontaneous emission can be written as NSP, which is equals to A21 N2 delta T. So here A21 is your spontaneous emission coefficient. 21 denotes the energy, or the atom is present in excited state first and then it will return to the ground state. So N2 denotes the number of atoms in excited state, and delta T is time required for this transition. Now the next most important method for the laser formation is your stimulated emission. So what is mean by stimulated emission? Why it is called as stimulated emission? Because in this process we are incidenting a external photon or a external energy to the excited atom. In this diagram we can see all the three processes, that is absorption. In absorption, what will happen? The energy of photon h nu will be incidenting on a ground state atom, so it will jump to the higher excited state. And in spontaneous emission, the atom present in excited state, it will drop down to the ground state by emitting a photon of energy h nu. And in stimulated emission, what will happen? We are providing the energy for an excited atom. In spontaneous emission, we are not providing the energy to the excited atom. It will drop down to the lower energy state by its natural tendency. Whereas in stimulated emission, we are forcing this atom to the drop down to the ground state. That means we are providing the extra energy to the excited atom so that it will jump to the lower energy state. And during this process it will emit two photons. So what are these two photons? This two photon, first photon is the photon which is absorbed initially, and this photon is this one photon. So this two photons are in phase with each other. So therefore in this stimulated emission you will get a highly coherent light. So what is mean by stimulated emission? A photon of energy h nu can be induced in an excited atom to make a downward transition by releasing the photons. And this process is known as stimulated emission. And the transition can be written as A star plus h nu. It gives A plus 2h nu. That means initially h nu energy of photon is incidenting on an atom in an excited state, that is A star. So it will drop down to the ground state, that is A, and it will gives us 2h nu, that is 2 photons. The number of atoms in a stimulated emission can be written as NST, which is equals to B21 N2 Q delta T. B21 is what? The stimulated emission coefficient. Here the atom will be dropped from second to first, that is excited state, to the ground state. N2 is the number of atoms in excited state, Q is energy density, and delta T is time required for this transition. So this all about the three processes in the formation of laser. So out of which the stimulated emission process is most important for the formation of laser. Now we will discuss the difference between spontaneous emission and stimulated emission. So the first point is the spontaneous emission is the natural process, because we are not providing the extra energy to the excited atom, so it will drop to the lower energy state by its natural tendency. Whereas the stimulated emission process is an artificial process. That means we are incidenting an external photon to the excited state atom, and therefore due to the induced photon the atoms in excited state will be dropped to the ground state, and this will is a artificial process. Second point is the process cannot control from an outside. In spontaneous emission is a natural process, so we cannot control it from outside, whereas the stimulated process is controlled from outside because it is an artificial process. In spontaneous emission, the photons emitted are in random direction, so therefore they are not in phase with each other. Whereas in stimulated emission, the photons are emitted in the same direction, so they are in phase with each other. Now the next point are in spontaneous emission, all the emitted photons are not in phase, so the light is not coherent. Whereas in stimulated emission, all the photons are in phase, so the light is coherent. In spontaneous emission, you will get only one photon, so there is no amplification of photon will be takes place. Whereas in stimulated emission, the light amplification will be takes place. Next is the spontaneous emission. In this process, all the photons does not have a same frequency. So, the photons which are emitting due to the spontaneous emission are not a monochromatic, that is polychromatic. In stimulated emission, all the photons having same frequency and same wavelength. So, the light which is emitted by the process of stimulated emission is monochromatic light source. And the last point is the spontaneous emission is not useful for the formation of laser, whereas the stimulated emission is useful for the formation of laser. So in today's session, we will discuss the different laser formation processes and the difference between laser light and ordinary light, and spontaneous emission and stimulated emission. So this is all about today's session. Thank you all.